This is Michael DuBose again, and for our third lab this semester, I'll be calculating the mass of a black hole. So how would you calculate this mass? Well, first of all, you need to understand Newton's first and second laws. Final velocity equals initial velocity plus F net over m times change in time, and then position final equals initial position plus the product of velocity, average, and time. And also, net force is equal to the derivative, the change in momentum over the change in time. So in order to make our calculations, we have to separate net force into both its parallel and perpendicular components as it goes across, as it orbits around the black hole. So here we have a program that's going to show an object following an elliptical pattern around the black hole. So as you can see, the object is orbiting around it, and you can see it's both its perpendicular and its parallel forces being expressed as vectors here. And our program here is going to give us the exact mass of the black hole. So as you can see, the initial conditions for our code, we had the gravitational constant, we had the mass of the star, the change in time, as well as a few other factors. So what does this mean? Net force, the total of parallel and perpendicular, is different from net velocity, as net force is a function of acceleration because of Newton's second law, which states that force is equal to mass times acceleration. So in our terms, net force changed as the net acceleration changed. Yeah, the net force changed as the net acceleration changed. So i.e., you can have a negative force, but a positive velocity example. So a good example would be shooting a ball in the air. So it's still a negative force, but it is a positive velocity. So here's an explanation of the code. As you can see, the momentum principle is that momentum equals mass times change velocity. Here we coded for Newton's second law, which is net force is equal to the change in momentum with respect to time. And then, as you can see here, you have the unit vector for magnitude calculated here. Next, you have magnitude of the dp over dt, so the magnitude of the net force. And the unit vector is the force in the parallel, that unit vector times the unit vector. So it would be the magnitude of the net force times the force in the parallel direction, which would be the unit vector there. Obviously, you can see that net force of the perpendicular is equal to the total net force minus the parallel, because parallel and perpendicular components make up the total net force. This function finds the mass of the black hole. This equation is found by manipulating the gravitational force equation. And then finally, we were asked to confront the question, what if, here. So as the star is following the same path, we can assume that the gravitational forces exerting on the star at any given time is equal to that of the original black hole. Therefore, we'd be unable to notice any change in the system.